Hi everyone, my name is Bengü Fetiler. I am studying Electrical and Electronics Engineering at İzmir Captioning University. I'm going to present my graduation project and its name is GRU-based automated video captioning on Android mobile devices. First, I want to show you the outline of the project. I'm going to talk about motivation of the project. Then in video captioning part, I'm going to explain what video captioning is and which model I used in the project. Thirdly, I'm going to mention methods that need to use in the project. Afterwards, dataset I use, results of the project, and conclusion. Today, developments artificial intelligence have positive effects on human life as well as on technology. And disabled individuals try to handle with many problems in daily life. And the studies are continuing increasingly today to better adapt the disabled people to the social environment and to eliminate the problems that may arise. In this project, it's aimed to develop a smartphone-based application that will enable visually impaired individuals to solve the difficulties they may encounter. Accordingly, the system performs video captioning by combining natural language processing and computer vision, which are the main topics of artificial intelligence. Video captioning is the description of an action or event in the video by taking the video efficiently through text and by the natural language structure. Video captioning, which combines natural language processing and deep learning, is now frequently used in many areas, including television programs or YouTube videos. In order to better understand the model I used, I would like to mention about seconds-to-seconds model first. Seconds-to-seconds models are a special class of recurrent neural network architectures that are often used to solve complex language problems. This model can be used as a solution to any sequence-based problem, especially ones where the inputs and outputs have different sizes and categories. It is used in applications such as machine translation, speech recognition, and video captioning. Sequence-to-sequence is seen as one of the best solutions for video captioning. Therefore, the model performed in the project based on this model. And this is the general representation of the encoder-decoder sequence-to-sequence model. The Microsoft Research Video Description Corpus dataset is one of the frequently used datasets in video captioning. And this dataset includes approximately 1,970 videos. And these videos are collected from YouTube. And also these videos are approximately 5 and 20 seconds. The seconds-to-seconds model was trained with these datasets. The videos were split as train, test, and validation with these weights. And 70% for train, 20% for test, and 10% for validation. The videos are taken from the MSVD dataset to be used in the created model. They were separated into 8 frames each. Feature vectors for each frame were extracted using Inception v3 and NASNet architectures. Feature vectors will be the CNN outputs of the model. And GRU encodes the frames one by one as input, taking these CNN outputs applied to the intensity values of each input frames. You can see the demonstration of encoder RNN on the slide. Encoder reads the input sequence and summarizes the information in something called the internal state vectors and context vector. We discard the outputs of the encoder and only preserve the internal states. This context vector aims to encapsulate the information for all input elements in order to help the decoder make accurate predictions. CNN features will be an input for GRU layer, as you see. Modeling long-term dependencies for RNN is a challenge. GRU is an implementation of multiplicative models that try to solve this problem. And it is an example of memory recursive networks. And GRU is pretty similar to an LSTM. While the LSTM structure uses memory cells for long periods to store information, the GRU structure provides information flow without the need for additional memory cells. In this project, GRU structure is used to increase the ability to learn complex relationships of data and to produce successful captions. GRU has two gate vectors, and these are update and reset gates. As I said, CNN features will be an input for the GRU layer, and then the encoder output will be an input for decoder. In embedding layer, we include the captions we previously tokenized into the decoder as the encoded vectors of tokens. The decoder takes the encoder output vectors and outputs a sequence of words to generate captions. To embed the model in Android, the model must be quantized first. Quantization is the technique of performing operations in a low precision format or converting high precision data formats to low precision data formats. To allow more and better access to the end users, the representation of the models deployed for inference needs to be much more compact than their representation while training. Another thing to keep in mind is that backpropagation needs high precision representation for the model weights. However, during inference, the models are much more robust and do not require a high precision representation. Thus, for example, a model of size 100 megabyte representation can be quantized to be of size 70 megabyte. Then we should convert quantized model towards script format. And we should save file. And finally, we should implement this file to Android application. In this slide, you can see the performance metric results. As you can see in the graph, performance metric results are given for two different CNN architectures. These are GRU Inception v3 and GRU NASNet models. These results for CIDR score. And accordingly, the highest performance metric scores were observed in the GRU Inception v3 model. And the highest score is 83% for Blue one. And this is the Android application of the project. And this is the main screen of the application. To get caption, you can choose a video from your gallery or you can capture a video using your camera. And you can see the generated caption on this screen, as you see. If If you want to get results in a different language, you can select a different language from the settings, and you can see the caption with the translation of the target language. As a conclusion, a GRU-based sequence-to-sequence model was generated and the MSVD dataset was trained. Video captioning has been performed for Inception V3 and NASNet architectures. A maximum 69% CDR score was obtained in the trained model, and a useful application has been designed for the visually impaired by embedding the model into Android with Python. Finally, I want to talk about future works. Different architectures for CNN will be trained, and then the number of GRU layers will be increased. Performance metrics for the enhanced model will be determined. Thank you for listening.